Welcome back. In this episode, we'll focus on low-level significant weather charts, SIG WX. These charts provide essential weather information for pilots, especially for flights operating in the lower altitudes, typically from ground level up to 24,000 feet. These charts help pilots avoid hazardous conditions like turbulence, storms, and low visibility, ensuring a smoother and safer flight experience. A low-level significant weather chart shows areas of bad weather that can impact low-level flight operations, such as thunderstorms, low visibility, fog, and precipitation. These charts are updated regularly and provide critical information to help pilots avoid dangerous conditions. One of the main features of the low-level SIG WX is its color-coded system. Different weather phenomena are represented in various colors, making it easier for pilots to identify regions with significant weather. For example, areas with heavy precipitation might be marked in red or orange, while clear skies could be shown in green or yellow. Let's break down the key elements of a low-level SIG WX chart. At the top of the chart, you'll see the station identifiers and the date and time of the forecast. The chart also includes areas of significant weather indicated by color, along with the location of weather systems like cold fronts and warm fronts. Next, you'll find information about turbulence. These charts often display areas of light, moderate, or severe turbulence at lower altitudes. Understanding turbulence data is essential for flight planning, as turbulence can affect comfort, fuel efficiency, and, more importantly, safety. Pilots can adjust their flight level to avoid these areas, ensuring a smoother ride. Let's now talk about cloud cover. Low-level SIG WX charts often show areas with cloud layers that might affect visibility. If the chart shows a solid band of clouds or low ceilings, pilots will know they may need to rely on instrument flight rules, IFR, instead of visual navigation. This is especially true in regions with frequent fog or low stratus clouds. Another critical element in these charts is precipitation. The chart will indicate areas with rain, snow, or hail at low altitudes. Understanding the precipitation data is crucial for pilots, especially when flying in storm-prone areas or during seasonal weather changes. Heavy rain showers or hailstorms can drastically reduce visibility and aircraft performance, so avoiding these regions is a top priority. Visibility is another key factor on these charts. Low visibility due to fog, rain, or snow can be dangerous for pilots operating at low altitudes. The low-level SIG WX chart will highlight areas with reduced visibility, giving pilots the information they need to adjust their flight path or prepare for an alternate airport in case landing becomes unsafe. Wind data is also included on the low-level SIG WX chart. Wind speed and direction are crucial for understanding crosswinds and wind shear. Areas with significant wind shifts or gusts are marked on the chart, alerting pilots to potential issues during takeoff and landing. Wind shear, in particular, is dangerous because it can cause sudden changes in airspeed and altitude, leading to turbulent conditions. A real-world example: let's say you're flying from New York to Boston, and the low-level SIG WX chart shows an area of heavy precipitation with moderate turbulence over your route. The chart also indicates low visibility in certain areas due to fog. As a pilot, you might choose to adjust your altitude or divert to an alternate airport to avoid these conditions. In mountainous regions, the low-level SIG WX chart becomes even more critical. Wind patterns and weather systems can change rapidly in these areas, leading to mountain waves, turbulence, and sudden storms. The chart will indicate areas with potential high winds or severe turbulence, allowing pilots to adjust their flight plan accordingly. Let's consider a flight from San Francisco to Los Angeles. The low-level SIG WX chart shows high winds along the coast, particularly at lower altitudes. This could affect the flight's route or altitude. Pilots might choose a different altitude to avoid the strong winds and ensure smoother conditions. For cargo pilots or those operating at low altitudes for agricultural flying, the low-level SIG WX chart is even more essential. These charts show weather systems that could affect payload delivery and flight times, such as storm systems or fog in rural areas. As a pilot, it's essential to understand the limitations of the low-level SIG WX chart. While it provides valuable information, it doesn't account for local variations in weather. Always cross-reference the SIG WX with real-time weather reports, including METARs, TAFs, and radar data for the most up-to-date information. The low-level SIG WX chart is especially useful for pre-flight planning and when making in-flight decisions. It's a key tool for ensuring that pilots stay safe in areas with unpredictable weather. The more you understand this chart, the more you'll be able to anticipate and avoid weather hazards. Let's recap. Low-level SIG WX charts show wind data, turbulence, precipitation, and visibility. They are essential for pilots flying at low altitudes, especially during takeoff, landing, or in storm-prone regions. Understanding wind shear, cloud layers, and precipitation helps pilots plan safer routes. In the next episode, we'll continue our exploration with high-level significant weather charts, SIG WX, which provide essential data for high-altitude flight operations and help pilots avoid stratospheric hazards. See you in Meteorology number 56, High-Level Significant Weather Charts, SIG WX, Part 1.